Yeah, so welcome everyone. Today we're going to continue the stream I started, 6 weeks ago or something at this point. Uh, the idea was to build an automated patch notes system like we have for our games. Uh, Not the whole thing, top to bottom, because it requires a website and all kinds of stuff. Although for fun, we could get into that at the tail end of this thing. But mostly about um, the parts that are for converting the notes that you take when you make changes in your version control system, in this case Git, have those automatically converted into some sort of a pre-parsed format that can be used in all kinds of settings, where you can also filter based on how you write the things, so that you can choose which things will show up in different versions of the patch notes and all of that. So I started that project on stream something like 6 weeks ago. Haven't touched it since. We're going to continue where we left off there. In that stream, it was like 2.5 hours, I think. And all we got into was a whole bunch of stuff about TypeScript and setting up TypeScript and talking about Node. And we got the project just kind of roughed out so that we got to the point where we could write TypeScript and compile it. So we're going to continue that, and that's it. So this is largely at the moment still just for fun. If I can actually put enough time into this thing to make it good, then we would probably swap this out for what we're currently using, which is another custom tool I made. But it's old, it's showing its age, and it's not very good. So that's kind of the hope, is that this will turn out to be for that. So if you have questions as we go, just ask away. It's this, we're getting into the weird nerdy stuff of development, which is it's documentation. It's something that it's hard to care about for a lot of people, but it's really important, and it helps in particular you to share what you've been doing with the people who use the stuff that you make, whether it's a game or some other kind of software. So let's get into it. Like I said, ask questions if you've got them, and I'll just keep on kind of looking at the chat as we go. Oh, good. It looks like the chat didn't evaporate. So that's nice. We23, welcome. Omnicar, welcome. I should have said hello to everybody. Zippy Dash, Sorrows the Warlock, Bryce Taylor, welcome everybody. There's probably some other people in here not making any noise. That's okay. You do you. Right, we're gonna get into it. So where we left off last time, whatever that was, long ago, was we had, actually I'll flip over here to our GitHub, where I push this. It's public, so all the code is here. You can, so last month, yes, you can see. We actually can just go see when the last time this was. This was April 1st, April Fool's Day, so more than a month ago. Yeah, about 6 weeks ago. So now you can kind of see where we left off, what we were doing, and we can then continue from there. So what we had was this skeleton of a project. All it has is a source folder and then a README, which is what shows up here. If you're not familiar with GitHub, GitHub takes the readme.md file and converts it to HTML and then shows it right there, which is a nice little feature. And you can see we got some just kind of config things in here. Talked about this a lot last time. I don't want to rehash it because then we'll just never get onto any actual code. But if you have questions as we go, then I can hit those. So here's that project locally, just as normal Git repo. You can see over here, this is my tree of all of my files. So you can see my source folder that you saw also on GitHub. You can see these other files that are controlling the behavior of my development environment. And then we see this kind of grayed out build folder, which is where we ended last time. We were able to run the TypeScript compiler and cause it to create this build folder with all of this stuff in it. So this thing is grayed out because it is in our gitignore file. We're telling this to ignore everything in build because we can build it. So the general rule of thumb is that if something can be recreated from something else, then there's no need to actually put it in your Git repo. So that's what we're doing here. That includes our node modules, that includes our build folder. Both of those can be recreated. All right, so what's the next step? Like I said, we left off with having the source folder with these various files to control things. So we've got this temp file here we don't need anymore. Stick with that. With these various files that are not doing anything at all yet. We're just kind of setting up the hierarchy of where things are going to show up. We've got this package.json, which describes the project and where it will appear on the npm repository once we publish it, which we have not done yet and won't do for a while. tsconfig, which describes how TypeScript is going to work. So the next thing to do is to finish putting everything together to make it so that our coding experience is really good. I'm a tools first developer, so I make sure my environment is just stellar before I actually write any code, because writing code in a bad environment where you're not getting full support from your tools just is a sucky experience. Bryce Taylor asks, what are your thoughts on checking the package-lock.json? So this package-lock.json file gets updated anytime you update your package.json, and conceptually the idea here is that it then captures every version, like the exact version of all of the things that you are using in the moment, as well as all of their dependencies that you don't install on purpose, that just kind of come along for the ride when you install other things. And it just kind of records the exact versions of all of those so that you can then use other ways of installing things. And for npm, it's called npm ci. It looks like this, npm ci, for continuous integration, probably, where this thing will then use your package lock file to install everything to ensure that the versions are exactly what you intended them to be. So I don't know, I'm kind of two minds on this. I do currently check in my package lock because it actually is not reproducible. In the moment when you actually do an npm install, the exact version that gets installed is not necessarily what you've put in here. So here here's like my TypeScript dependency. I've got it at 4.2.3. When I'm doing an npm install, I may actually get a version higher than this, because this little caret here is me telling npm, I want a version that is compatible with this according to some particular versioning rules, but it doesn't have to be exactly this version. I can instead tell it to use an exact version, or I can change sort of how flexible those rules are. But the default is that you get when you do an npm install is this type, which I think allows you to update the minor version, but not the major version, and a handful of other rules. End result is that now if you pull this project onto your machine and you run an npm install, you may end up with different versions of things than I have. So the benefit of the package-lock.json is that in production, so if you're now running a build on a remote machine for the final thing that creates the package that gets uploaded or whatever, this is the way you can then guarantee that the versions are exactly what at some point were last used in development. So I don't know, it's hard to say how much that really matters. Ideally you would be running tests after you do a build anyway on the built stuff, in which case it shouldn't matter. But yeah, and then further, because the package lock sort of describes what's going on, it doesn't control it under your normal behavior, then it doesn't really reflect what's going on in your local environment that well. And so yeah, so I guess the long and short of it is it doesn't do a good enough job at ensuring that everything is the same to feel like it's necessarily worth it. So I think you could go either way, and I think there are arguments in both directions. I think it's hard to make a strong case for the package lock being a particularly worthwhile thing. As CI is clean install, that makes sense, yeah. So use it for continuing integration, but it's actually clean install. So thanks, Bryce, for that clarification. All right, so the next thing we're going to do is add our linter. Then we're going to also add a formatter, and then we'll actually be ready to finally start coding this project up, which is hilarious. Normally this stuff doesn't take as long as it's been taking because I'm doing it on stream. I'm talking a lot. I'm answering questions. So there is still a lot that goes into setting up a new project with your full development environment ready to go to be a nice experience. But it doesn't normally take, 3 or 4 hours or whatever this is going to collectively take. All right, so let's add our linter. A linter, what is that? It has some origin for its name that has something to do with, lint traps in the same way that like bugs have some origin that is maybe apocryphal, who knows. The idea of linter, just like you get lint on, a shirt or it's in a lint trap or whatever. It's just stuff you want to get rid of, I guess, but it's not the best metaphor in the same way bug isn't. It's not really a good metaphor, but it becomes a thing that you just sort of understand once you see it enough. So a linter is a tool that analyzes your code and looks for problems. That's basically it. It's different from a compiler, which actually compiles the code and then allows it to run. And it's different from runtime error checking, which is happening while the program is running. So linter is typically a static analysis tool, meaning it looks at the code itself, just the code, and then it looks at the rules that go into code and what code could possibly be, and it result in something that successfully compiles, or in something that not only successfully compiles but doesn't throw errors at runtime and so on. So linter just looks at your code. With the JavaScript and Typescript ecosystem, ESLint is far and away the most popular linter, though there are more than just the one out there. So that's what we will use. So we're going to npm install ESLint. Also note, dash capital D, so remember that means install it as a dev dependency so that it won't go into production, just happens locally. ESLint. So this is also the one that VSCode, if that's what you're using as your editor, which is what I'm using here. VSCode has really good just linter or ESLint support out of the gate. I think it actually comes with a version of it also. It'll tend to be an older version. It doesn't just kind of just do things out of the gate. And so I always just install, I always install all of my dependencies, including my dev dependencies, even though many of them are built into an editor and so on, because I want to separate as much as I can the editor and my exact setup from what I think or what I want to be the setup for the actual project itself. That way, if somebody else goes and works on this project, they'll be using the same version of ESLint that I'm using, because they'll install it when they install everything else. They'll be using my same linter rules that I'm using, because I'm going to put them here instead of using global ones that I've put somewhere else, and it just makes for a better overall collaborative experience. So we've now added ESLint, and then we can do, so like I said the last time too, npx is the tool for running local executables that are installed by the packages that you download from npm. In the case of ESLint, it's called ESLint, so that's really convenient. And like I also mentioned last time, many of these really good tools, especially ones that have configuration files or complex configurations, have some sort of a command that initializes things. It's usually called a init, and it might show up as just init as a command, or it might show up as a flag called -- init. Typically, I just try one until one works. That way I don't have to, because each one does it differently. That way I don't have to memorize which one's which. And so what an init is going to do, yep, so that's looking for, there we go. So now what this is going to do is now walk us through some questions so that it can help us set up a configuration that's going to already do a good job for us instead of us having to set all the rules. With ESLint, there's something like, I don't even know, probably hundreds of rules that you can turn on or off or set particular settings for. And you don't want to go in and tweak all of those. It would just be a nightmare. You want to have a nice setup that just already is pretty good out of the gate, and then you can turn things off if you want to. So I want to keep my linting, which again is checking for things that are going to be a real problem. I want to have that separate from formatting, which is basically your optional choices of how I want the code to look. So that's whether I want to use semicolons or not. That's whether I want to default to using double quotes instead of single quotes to identify strings. All that kind of stuff that doesn't actually impact whether or not the code is going to work is something I want to be handled automatically by something else, which is the next thing we're going to do. So here you can see the options I've got. I can check syntax only, I can check syntax and find problems, and then I can also enforce code style. So I don't want to enforce code style with ESLint. The main reason is it makes you as the developer constantly see all these little squiggly lines and things of things you're doing wrong because you forgot a semicolon or whatever, but you can use an automatic formatter to just fix that for you on save or whatever. And so you never need to see that it's wrong. You never need to see that your spacing is bad because you didn't tab this thing in as much as you had tabbed the line above it, because something can just fix that. So why waste the mental energy even seeing it and worrying about how it looks when you can just have something fix that for you? So we're not going to opt into that. I honestly don't know the difference here between syntax only and find problems. I've just always opted for find problems because problems seem like the kind of thing I would want to find. So presumably this is opting into more and more rules. Again, I don't know what kind of problems we're talking about here, but that's always the one that I choose. It's going to ask us some other questions so it knows, because ESLint by default does a handful of things for sort of standard JavaScript. And then you can add plugins that add new rules. And you can make your own plugins too, that you can just load into ESLint so that if you want things to behave in a certain way, or if you've done something really weird in your environment that the linter doesn't understand is fine, and so it keeps giving you errors, you can make your own rules and tell it how to behave. So here we're going to use, I believe we decided to use modules for this, which we also talked about a lot last time. Yeah. So this is, in short, we get to choose between common.js, which is a standard import-export syntax. We can see down here, require/exports is what it is for Node, and the module import-export syntax, which is now standard for browsers and is kind of becoming the standard for every new JavaScript-y thing. So when I set this project up a few weeks ago, I set it up to use modules just to kind of be part of the future, you know. So that's the format we're going to use. So we'll just say JavaScript modules. We are not using any front end. We're just doing Node stuff. We are using TypeScript. And again, ESLint comes with some baseline rules and things that it can do. These questions are for adding other stuff. So TypeScript comes as a extension basically to ESLint. Where does it run? We're going to run in Node only. And then we get into these sorts of questions that like don't matter that much. Let's see. Omnicar asks, would find problems, that option for which ESLint choice we want, point out things like undefined variables while checking syntax only would not. That's quite possible. That might be exactly what that is. And if it is, then that is the kind of thing we want, because we want to make sure we're not introducing likely errors. And part of the reason you might opt not to do that is because once you add TypeScript into the mix, then TypeScript rules are their own thing, happening completely separately from ESLint rules. And so you might end up with actually a lot of overlap where you may decide to turn off even more things from the linter, because between TypeScript and then an automatic formatter like Prettier, you might be already handling all of those things. I'm just not sure because I don't know what problems means specifically. So I'll just opt into all of those, and if I need to turn some off, then that's no big deal. Okay, so then the final question, you'll see this a lot for configuration files, is a lot of programs that need configs will give you options of the kind of format that you use. There's a thing called, let's pull it up, called Cosmic Configs. Cosmic Config. That is sort of a set of, is this the thing? I'm not sure what the site is that describes it. Oh, here we go. This is probably what I want. Yeah, there we go. So Cosmic Config is kind of a set of standards for how a configuration file can be loaded in its format. So you can see here basically what it does is it first looks for a property named whatever the name is. So in this case, if we're using ESLint, it would look for a property in our package.json JSON file called ESLint. If one's not found there, then it looks for something called dot, in this case, ESLint.rc, and if that's not found, .ESLint.rc.json, et cetera, et cetera, et cetera, giving you a whole bunch of options for how you want to keep your configuration file, both in format and location, and then all of these will actually work. It'll just like do a series of fallbacks until it finds one. So we have that choice. Again, this is one of those things that for the most part doesn't matter. What I've found as I've been playing this battle with the whole module versus common.js question, a lot of things tend to come out easier if I have my configs be in stuff that isn't JavaScript, because if it's in JavaScript, then it also has to be in the right format, and not all the tools handle this correctly currently. So I've had some trouble with that in the past, and I tend to then end up using YAML instead for that reason. Finally, would you like to install the missing plugins? So as I said earlier, with ESLint, you can add plugins to add the different rules. In this case, they're saying to get TypeScript support in our linter, we need to include this new TypeScript plugin. So we'll just let them do that for us. So the ESLint, it's a really robust tool set. It's used by just jillions of people. And so it's tools like that you end up having these really nice interactive experiences with when you're initializing them that help you pick the right things, and also help you set up your environment so you don't have to do all that work. So now you can see in here we've got this stuff. We've got the package.json changed, or should have. Yeah, the package.json has now changed to add these two, or I guess these three things. We've got our ESLint, and we've got these two ESLint related things. for TypeScript, so a parser and a plugin. I don't know why you need both of those. It seems like you'd only need one thing and it would do both, but presumably there's some meaningful difference there based on how the ESLint system works. Those are installed. You can see it also added this .eslintrc.yml thing, and so that was like I noted with that cosmic config thing where we have these different names that can work, and so I could actually rename this to a few other things and it would still work, but this is the default. All right, I can see how it set up a very, very minimal config file for me, which is great. It didn't actually specify any particular rules. Note that when you add, so here it says has extends, where I've got ESLint recommended, and then this plugin recommended. These actually are a bunch of rule sets, so I don't see them down here. They're not explicitly specified down here, but there are a whole bunch of rules being specified. These things that are basically being sort of imported. So I may decide to then override some of those as time goes on, which I would then do down here. But yeah, I can see there's not much in here. It's saying my env is ES2021. This is a version of JavaScript basically that I'm using Node. If I was in a browser, if I had said yes to the browser question, that would show up here too. And that would give me things like, it would tell me that that the keyword document exists, for example, where since I'm in Node only, then ESLint should tell me that that's an error because that doesn't exist. So that's all ready to go. Now we've got our linter, which brings us to the next part. So I'll go ahead and commit this change. See, we're using dev. Looks like, yeah. Get it. Again, that was an alias I made. I mentioned last time. This is just short for get add -A and get commit -m. So I can just write get it and then put my message in. So here we have updated our development environment. And so as I also noted, I'm using the syntax that we're going to, so the syntax I'm using down here is similar to, but extended from the tool that I mentioned last time called, oh no, what was it called? Conventional changelogs. So now I'm just adding a little bit to it, and as I write the commit messages for this project, I want to make sure that they adhere to the same thing that we're going to use, so that we can use this very project to test its ability to parse and format our Git messages into changelogs, into patchnotes. So here's the pub, we'll just call this dev, that's totally fine. And so basically the way that this works is you have some sort of category of type of change, which could be feature or feats. It could be docs, which you can also see. It could be tests. It could be a refactor. It could be performance. A whole bunch of different things, plus shorthand versions of those. That kind of puts them into the category, and that's used to allow other automated things to do some work. So if we know, for example, that perf means performance, and we have some automated tool where if we claim we've made a performance change and we have a suite of performance tests, then that could be the signal to automatically run a performance test or something. Similar to with versioning, where if we add a feature, then we can have our automatic tooling that then goes to version it, say, oh, we've added a feature, so we need to do a minor version bump, the middle number in semantic versioning. Or if somewhere it sees the word breaking, so that you've basically indicated you made a breaking change, it'll know it needs to do a major bump because, anyway, that's stuff about how semantic versioning works that we'll get into because we have to know how it works to make this thing behave the way that people would expect. So we're going into feature pub dev. So this is just add ESLint and a basic config. That's that. Looks like I don't see any questions in the chat. I'm just assuming people are in the chat because I don't see a way for me to know that. Perhaps I'm just talking to the void. Oh, here we go. Users in chat. There's a handful of people in here. Cool. How do I get back to my chat? There we go. Perfecto. Right, got our linter. Now we're going to make it pretty. So this is using Prettier. npm I Prettier. Minus -d again. So Prettier, which I've mentioned I think a bunch of times probably, is another tool set for doing formatting. So it's made for formatting JavaScript. It also works on JSON and a few other things. And the idea here is that you're just opting into a rule set for what it means what the code is supposed to look like, where spaces are supposed to go, whether you're using tabs or spaces, how much indentation you want, whether you're using semicolons, what happens when things get really long in a line, so what the rules are for breaking it apart, whether you're using trailing trailing commas, just all kinds of stuff. So what Prettier does is it just chooses almost all those rules for you, and then you can run it on your code. So basically analyzes your code, applies the formatting rules, and then just updates your code accordingly. So again, these are nice because it doesn't give you the option to just burn time trying to decide how exactly you want your code to look, because it just looks however Prettier decides it's going to look, and that's that. So now we've got Prettier installed, which means it's available, so we can do it for auto formatting. And what this would do then is, so we can do, we'll add a Prettier ignore, touch.prettier ignore. So this trick where you add a file called the name of the thing, ESLint, Prettier, whatever, ignore. It's kind of modeled after git ignore, which is a thing if you're familiar with Git that you've seen a million times. And so this is a kind of file. You can see that VSCode knows what it is, so it gave us the Prettier icon for it. This is telling which things Prettier should not pay any attention to. So I'm going to tell it to ignore the build folder because we don't need our build code to look pretty. Who cares? I'm also going to have it ignore node modules, which there's a good chance it just does by default, but just in case it doesn't, we're going to do that. I'm going to do a similar thing with a ESLint ignore, because I also don't want the linter to give me a bunch of errors from my build code, because the build code is going to not follow the same rule set as my original code, because it'll strip a bunch of things out, and so it'll still be valid JavaScript, but might not adhere to the additional rules I've opted into with ESLint, and I don't care. So I don't want to get those just sort of that kind of chaff, that fit this just noise of errors that don't matter. So I'll just copy .prettier ignore to ESLint ignore. Which is a nice thing about these kind of common formats and names of things with the common behaviors is that if you kind of know how one works, you know how another one works. If you want to have some rule set that makes sense for one thing, it probably makes sense for other things. It's just a simple kind of copy paste affair. All right, great. So now we've got Prettier installed, which should allow us to run it. So if now, for example, I've just got no code in here. So let's put some code in here just so you can see it in action. Const a equals hello world, some other field, and then we'll put like a number in here, whatever. Actually, before I do any of this, I'm going to reload my window. Hopefully let me, looks like it's trying to do something right now. There we go. So one of the things I've found is that when I update configuration files, so my ESLint config or my Typescript config or whatever, any of these, that a pretty high percentage of the time, the stuff that VSCode is running, because it's running a version of Prettier and all that kind of stuff live, and it doesn't always notice that there's been a change. So this is particularly true with ESLint. And so I'll tend to, after I've made a bunch of changes to configs, just reload my window to make sure everything got reloaded correctly. All right, so here we've got now, if you noticed, I wrote this thing originally with quotes around it, and I didn't have a space here or a space there. And we can try to do this again, and there I had a whole bunch of spaces. And then when I saved it, all those spaces went away. The first time I saved it, this thing got changed so that it didn't have the quotes around it. It added spaces, all that good stuff, right? So that's Prettier doing its thing, and it's because I have Prettier installed, and I've got a setting in VS Code that tells it to format on save. So if you were to look for that, if you were to do a Control-Shift-P, or just Control-P, that pops up this little window in VS Code, and then put a right angle bracket in there, and then say I want to open my preferences, which we'll do not as JSON. We can do as JSON, that's fine. Go to our workspace settings. I guess there's nothing in here because this is a new workspace. Let's just delete this for now. Don't want to make that yet. Okay, let's do preferences. Look at it as the UI. So now in here, if I were to go look for format on save, then this thing is checked. So if you're doing like a whole bunch of batch editing of files and that kind of stuff, you're going to want to turn this off because it slows down saving really dramatically. The nice thing about having this be the case is that as you're writing your code, just if you have a habit of hitting Control S, to save anyway, then it kind of keeps your code formatted and looking nice the whole time without you having to actually do that work. And then it also means that the code as you see it is basically what ends up in your repository, because by the time you've gotten there, you've already saved it, and so it must already have been formatted. You can't count on this, though, for other people, because if it's being set in VSCode to do the autosave, which is the place you really could be setting it, then if somebody else uses it, then they might be overriding that setting, or they might not be using VSCode to do editing, so it might not matter that you have that setting available at all, even if it's local. So you still need, if the formatting is really important, you still need to have other mechanisms to make sure that you're guaranteeing that things are formatted. But for your own development work, having a format on save is a really nice way to do it. Okay, so that's all that is. Which means we've now got Prettier. Prettier's done. And then the way that you would run this from the command line is just like with ESLint, where you could run npx ESLint. Then I'll probably tell the location actually. Tell it to run this on source. Then this is going to check all the files, and right now there's nothing going on in there, so there shouldn't be any errors. But that would normally print a log of errors. When you run it, it looks for your ESLint config file and your ESLint ignore, so that it makes sure it doesn't run on things you told it not to, and that it uses the rule you told it to. And then in the command line, there's a billion settings you can apply. Prettier works the same way. So I can run Prettier on my files as well. And you might have to tell it that you need it to run on Typescript files. I can't remember. Yeah, just worked out of the gate. Cool. So here you can see that this just ran and then reported what it did, because ESLint by default just gives you a report. Prettier by default basically also gives you not a report. It actually just sends the improved, whatever, the formatted code out to your console, sends it out on standard out. And so that's what happens by default. If you use the $-w, that means write, which is confusing because for other programs that means watch. But anyway, so that means write. And what this will do is not just fix the issues, but it'll also overwrite your file. It'll rewrite your file with the fixes that it has made. Here you're seeing this in gray because it didn't actually make any changes to those files. If it did, it would show up in white. And that's that. So you can get a sense of what these things are doing as you use them over time. Let's see. In the chat, Bryce Taylor says, some time ago, I seem to remember mentioning using Atom. Why switch to VS Code? So yeah, Atom, I used that for some time in my early JavaScript development. And I really liked it at the time. VS Code came out. VS Code is a little more recent, or at least its popularity is more recent than Atom was. The problem I was having was that my programming experience, my editor experience, was just getting slow in Atom. And so I think that is what caused me to look around for other stuff, and that was just about the same time that VS Code was kind of taking the scene. They have a similar kind of way of working because they're both actually, in effect, browsers. They're both made using Electron, which is Chrome. So they have kind of similar requirements, but since VS Code is backed by Microsoft, it has a lot more development resources, and they kind of very quickly just took over and just had so many cool features added to VS Code that were just there and had really good support that it just became, for my own purposes, a better tool very quickly. So that's why I ended up switching to it. There's some really cool stuff like Live Share is what they call it. It's an extension that's made by Microsoft. It's this thing down here, and so it's I guess it's like an official extension basically, but it doesn't come built in. But it allows you to just hit a button or share a link with somebody, and then they open it up on their desktop, and it puts them into their to their copy of VS Code, and they're basically now just looking at your project, right? And now you can collaboratively edit. It has audio chat and chat built into it. You can see like little, for each person's cursor, you can see their name and stuff. So you can see where people are. You can follow their cursor. So now if you're doing things like code review virtually or collaboration virtually, then you really can do it. And it works quite well. Sorry, I got an alarm going off. Not anything I care about. So yeah, I've been a big fan of VS Code since I started using it, and I wouldn't switch back to anything at this point, probably. right, let's continue. Great, got our pretty stuff. Let's now commit our changes. We got 5 files change here. Seems like a lot. Because we added Prettier, so that makes sense. Added Prettier, so that makes sense. Updated a README. Yeah, okay, so it's actually not that much, is it? It's always good to review your changes before you commit, just in case you did something dumb. I've certainly done that. Get it. We'll now do feet. Actually, what are all my options here for? Let's do a quick check here. Let's do a quick check for, what do you call it? It's conventional commits. Conventional commits. So again, this is conventional commits is what this thing is going to be based on. It's an extension of its behaviors. Like I said, this is the format. So this would be like your feet, and then optional scope is the thing we have in parens. The description, that pipe thing that I'm adding is something I'm extending it with. But I wanted to see what the common names were for this, which might not be in here. Yeah, it's part of. So refactor is one of them. That's pretty common. There's fix and feet that are both common. Let's see here. Quick summary must be that, right? Oh, here we go. Right. So you can have all kinds of types, but it's not. There's no requirement. According to conventional changelog, you can opt into other models. So the ones that they recommend are these. Which is a good set. So I think what we'll do here actually is we'll kind of grab these so we have them handy as a reference, plus fix and feet. And we will put these into our README. So first I'll do this. Feet, pub dev, add Prettier, and its config. Then what we can do is update this thing, and we can add a quick section on what do we call this? We would call this commit message types. Put these in here. Fix, bug fix. That way we can use both of those and they would both work. That's what it sounds like. Don't explain that anymore. Feet, feature. And then we've got things like build. I don't know what that would mean right now, but we'll keep it. That's fine. This is not for, well, I guess this is for just you to decide, right? Unless we connect automatic behaviors based on which one of these things we've chosen, then it doesn't matter what you choose. It's whatever makes sense for what you're trying to accomplish. CI, docs, style. So style would be changes that are, it's different than a refactor. A refactor meaning you're actually changing what the code is, right? Versus a style change might be changing indentation of something that literally doesn't matter. Because a refactor carries with it risks of changing behavior. Performance. And test, okay. So we don't have to strictly adhere to these. We can allow for all kinds of options, but having these handy as references for when we're making commits would be useful. This is also one of those cases where you can see how having additional tooling around this would be particularly useful. And the conventional changelog ecosystem has tons of tools for that. So that instead of you doing your normal git commit and then adding a message, you would actually call their CLI tool. And it would then walk you through a sequence of questions that you answer so that it will create a guaranteed, properly formatted message that will work for their system. So that's a very nice feature. If you're wanting automated patch notes, just kind of as an aside, and you don't care about the main issue that I'm trying to resolve here, which is the ability to differentiate which messages go into, or I guess it's the ability to take the same changelog or the same set of commit messages and create different changelogs based off of those, and then further to, in a commit message, have more than one change documented. So if you don't need those two features, then the conventional changelog ecosystem has tons of tooling, tons of it, and it's very confusing and hard to figure out where everything is. But if you can find it, then it's very, very useful, and so I definitely recommend that. Anything in the chat? Nope. Okay. So we got these kinds of things that we could have as options in here. So I've just been using feet. I think I got a docs in there somewhere. And then we can move on to the next part of the problem. Let's close all this stuff. Okay, cool. So we did it, right? This is develop, dev, env, setup. Is all this stuff that we just did. After a million hours of this stuff, and now we're gonna get into the actual work. So this is now features. Okay. So that was a lot of stuff that wasn't actually coding any functionality, right? So now we can get into the features. Now, when I'm building a tool that needs to do some stuff, I don't have an approach that I have found easy to describe in terms of how I break it down into like its constituent parts and start going. I mostly make sure I know what I want things to look like, and then I start putting together some samples of like if I have this thing and this set of inputs, the outputs I would want to get are these, right? Because I often find that just in documenting the intended behavior, that I learn stuff about what should happen. Here, we're building this changelog system that has to do a bunch of things. But the first thing it is going to have to do, well, I guess not the first thing. So two of the obvious things it's going to have to do are be able to read a Git log, right? It has to be able to look at a Git repo and get all the logs out of it. So it has to be able to do that. For a Git log, for a message that comes out of the Git logs, it needs to be able to parse it to identify the kinds of messages that we're talking about here and pull those out and store them as some sort of useful data structure. So it needs to do those two things. Between those two, the parsing part is independent, and it's also doesn't require anything else. It's parsing a string. That's all it is. So that to me feels like a really good place to start, because once we have that, then we add in the Git stuff on top, and we already are getting useful output. So that's what I'm going to start with, and then we'll kind of keep on building up as we go. We'll refactor as we go. For people who are really good at architectural problems in code, they may do a whole bunch here out of the gate and decide, okay, here are the different classes that I want. Here's how they're going to talk to each other. Here, they would figure all this stuff out ahead of time. That's not something that I'm good at. I've never been good at it, and so I do enough that I feel like I know what the big picture is going to look like, and then I just do a lot of refactoring as I go. And for me, that tends to work, but it doesn't work for everybody. Again, throw any questions in the chat if you've got them, and then we'll keep going. We've got, there's not a ton of people in here, which makes sense. This is the, you can't get much nerdier than this. So thanks to everybody who's popping by and who wants to get nerdy with me on this stuff. And it's pretty self-selected, so you could probably ask any kind of questions you want about this kind of nerdy stuff, and the rest of the group would be happy to hear it. So with that, we'll go to the next thing. So feature number 1 is ability to parse a string that is in the target changelog source format, and convert it into a, we'll just say useful, figure out what that means later, a useful data structure. Okay, so that's problem number 1. I think that's my goal for today, is to get that thing done. I enjoy these things actually, because it requires a lot of using regex and trying to figure out exactly how things could look, and it's kind of a fun little set of problem solving, just all by itself. So I think this will be a good project. All right. So with that, and I'm going to make sure that we're testing it as we go. So if we're doing proper document-driven, test-driven development, then we would say, what are we trying to do? What is the architecture to whatever extent we're willing to get into it, and then let's get some test cases so we know what we're trying to get to happen correctly, and then start coding against those test cases. So that's what we'll do. I've already got this test folder in here. There's nothing in it, but the folder does exist. We are using mocha.js for testing. There's Jest is the other super popular one for JavaScript. I ended up in the Mocha framework. I don't have any specific reasons why I'm not using Jest. It's just the one I ended up in. So I like it. Does a good job. And that's good enough for me. We're going to do tests with, let's see here. So when using Mocha, there are a few ways to use it. The way it's expected to be used is that you point it at a folder, like a folder of JavaScript files. And it will then just basically run those files either in parallel, because you can tell it to run in parallel, or back to back, but basically in kind of whatever order it wants. From there, you can do some things to have more control over that behavior if you want to. But the nice thing about that default behavior is that because you now have to work against it to make it do things like run tests in a certain order or something, then it encourages good test running behavior where each test is really standalone so that it doesn't have to run after some other test. So let's call this first one, parsing. All right, so now if we're using Mocha, it doesn't know what describe is yet. Right. Ooh, nice, yeah, okay. So this is TypeScript telling us this, which is fun. So describe is a global function available in Mocha. And so basically TypeScript doesn't know what this is, right? But it fortunately is smart enough. I don't know if this is because it's like a really common problem, so it's just built in some way, or this is where the source of this message is coming from. But the nice thing is it doesn't just tell us that it doesn't know what this is, but it also tells us where we might need to get that. So in my case, we actually haven't installed tests yet, I don't think. No, we only have these dependencies. So we need to actually install our testing dependencies. npm I, that's our install, -D, that means it's a development dependency that won't go to production. We're gonna do that with Mocha, and then we're also gonna do that with, I think types don't ship with Mocha, I'm pretty sure. But just in case that's changed, we'll just install Mocha first and then see if that fixes our missing types problem or not. And it's also possible that we need to update our ESLint settings. So that ESLint, because ESLint is also checking for errors, and so if it doesn't know that describe exists, then it also wouldn't tell us that. Or it would also show an error. Okay, so we did that. So describe here. Yeah, we're still need our types. Yep. So this is something I mentioned last time as well. There's a community-run project called something types. What is it called? I don't know, but it's at the @types in npm, and it's in GitHub. It's just this huge mono repo where the community has provided types for all kinds of really popular packages. That includes Mocha. More and more packages are shipping with types these days, and so you don't need to do this as often, but I've still found I need to do it for most of my dependencies. Okay, so I've now added that type, and so now the error we're getting is that we're using this wrong, which is perfect because that means that TypeScript knows what this is. The linter's not telling us there's any issues, so we can just go ahead and start using it. So that's great. So we're going to do a describe. So describe is basically a way of bundling specific tests together in Mocha. So things that you want to have like a setup and teardown events that they share, or have like a before each and after each test behaviors, those will all get grouped together into one describe. You can technically nest describes, so it's like nesting one group instead of another. It's not going to behave the way that you expect, so I recommend not doing that. It's possible, and it is okay if you understand what's happening, but what is happening is probably not what you're thinking is going to happen. So don't recommend it. So this describe function is basically registering a suite of tests with Mocha. And typically you'll just give it a name. It's like, what is this group of tests going to be called? So in this case, we'll call it commit message parser. And then you pass it a function. And this function is basically going to get called by Mocha. So if you imagine the sequence of events that's happening here is that Mocha loads all these things up. Mocha just runs through Node, but basically a whole bunch of other stuff runs first, where these global functions get created and all of this by Mocha. That all happens invisibly. It's just like magic, and then all of your modules that are in your tests get imported, and these describes, these are function calls, right? So this is describe. I'm just calling a function called describe, and I'm passing in 2 arguments. One is a piece of text, and the other one is a function. So basically, Mocha calls all those functions, and what those functions do is basically register these suites by giving it a name, storing this function, and then later on it calls that function. That function in turn has a whole bunch of tests inside of it. Each one of those tests is another function call that basically registers something that's going to happen via a function, and so on and so forth. So it's a lot of nesting, it's a lot of function set of functions, and the syntax is really convenient once you get used to it. But like I said earlier, this sort of like what it's actually doing is a little tricky to mentally keep track of, because if you're not paying really close attention to scope and order of events, actually sorry, more importantly, it's not about paying attention. It's that you have to really understand scope and order of events for it to behave the way you expect if you start doing weird stuff like nesting or wanting one test to run before another one and so on. So, sorry, just checking the chat. Nothing in there. All right, so we're going to make our parser, and now we're going to have our first set of tests. So it's the keyword it / function name it is what Mocha uses. And the idea is that it allows you to express an idea grammatically in English, right? So I can say it can do this, it will do this, it does that, or whatever. And so I write this thing as if I'm just writing a statement of fact about what this thing is supposed to do, so that when I get the output, I get a little green check mark next to, check mark, can do whatever, right? So that's why it's written that way. It's a weird, really weird function name, but it's written so that you can read it out loud in an easy way. So in this case, the question is, what are the things we want to be able to do? What are the input-output relationships? And so there are a few things we can do. We can basically take, probably the actual thing to do here is to take a sample, like a complex sample case of a source message that we want to get parsed successfully. And then we can write tests to see if each one of those tests can actually do the specific aspect of the parsing that we want them to be able to. So let's do that. I think maybe something here. Okay, so I'm going to install a dependency here. I think we'll probably need it for other stuff too. Bscotch utility. So I have a utility suite that has all kinds of fun stuff in it that I use across my projects. I'm going to install that so I have those available. Okay, so now we can say here is const undent. It doesn't know. I'm not getting my autocomplete yet. That's the other thing too. When you install new modules from npm, then Typescript, your Typescript language server that's giving you all these hints and stuff, doesn't necessarily know about it right away. And so a way to resolve that is just to restart your Typescript server, which is no big deal if you're in a small project. If you're in a big project like Rumpus, like our web infrastructure, it takes like 3 minutes to reboot, and so that sucks a lot. But here's no big deal. So then hopefully, don't know what this is yet. Come on, buddy, you can do it. Maybe not. Maybe I need to use it first in some context. Okay, so we'll do an import from Bscotch. It doesn't know what this is. Did I install it? Bscotch utility. I did install it. Did you mean to set module resolution? Oh, to node. Yes, I think I need to do that. Yep. Module resolution. Yeah, this has to be set. There we go. There we go. Okay. So this is tsconfig, which again, tsconfig can make TypeScript for a browser or for Node or for other kinds of contexts, and each one of those behaves a little bit differently. So fortunately, VSCode and TypeScript have been updating in parallel, and they know what the common problems are, and so they're giving us these helpful messages. All right, so I'm going to get this function called undent. Oops, let's put that back there. So undent is a template function. So what it does is it takes a string template, which is a JavaScript feature that just is any text between 2 backticks is a template. So you can use these template functions to it's basically a kind of a shorthand way to then run them through some sort of function to do something. So I have this function called undent, which basically allows you to have a string that might be doing a whole bunch of stuff. Oops, let me just save this as something. Const message. What's that? So what this does is allows us to write a multi-line string in the code without having to shove the string all the way to the left so that there aren't any tabs in it, right? Because otherwise it would be indented. And so what this undent function does is it takes whatever your minimum indent is. If it looks, so basically it ignores the first line, and then if there's a last line, it ignores that too. And then it looks at whatever the minimum indent is between the actual string, which is all the way to the left here, and then all of the lines inside whatever you put here, and it chooses that as the left side. So it basically shoves everything to the, that way you can have things be to the right that will get shoved to the left. So if you're now making strings, multi-line strings instead of indented code, you can still have it look nice there, and then get the string that you want out of it. So we're gonna make a thing here called message undent. So this thing is going to be our test message. So we'll do a feat. This one we're going to do it just the boring way. Added some feature. So that's a thing that should just work, right? We can say here is a body for that feature that we've just added. It has multiple lines. And then we can add another one in here. Then we can say chore did something we don't want to report. This is the chores body. It shouldn't even show up anywhere. And then we're gonna have let's put some docs in here. Now we can do some fun stuff. So now we'll say docs, and we'll do a category. So this is that idea where if I put something in parens, it becomes a category that I could group things under or highlight differently, whatever. We're just making this up, right? It can be whatever we want. So this thing, we'll call it, what should we call it? We can call it, we've been doing dev as one of the things. Updated something in the docs, and then we can try something else like a fix. And then here we'll give it a stream. So that was that idea, or maybe we'll call it a tag. It's probably a better word. So we can give this one a tag, which we'll call pub for public. And then this one will go into, yeah, I'll put this one in dev too. That way it's two of the things in the same group. Fix something, it's broken. I have a second line on this message. Here is the fixes body. Then here is a footer with some keywords in it. And so this could be things like closes number 55 at someone. So to be careful with these because GitHub does a whole bunch of useful stuff for us automatically, and some of that is parsing your Git messages and then doing things as a result. So this whole like closes number whatever thing is you telling GitHub that if there's an issue that's number 55 or a pull request on this repo, that it'll automatically close those things when you push this. So we do have to be careful here. So there is no issue 55 at this point, so this would never happen because it happens on push. So that's fine. The other thing you can do is @ people using your @ symbol. So you can @ somebody on your team, you can @ some complete rando, somebody else in GitHub, right? Just by adding their username. In the case of the patch notes that we make for our games, we use @ plus rumpus user ID so that we can add a message like thanking a user because the reason that change happened was because they had submitted a bug report or something. So I want to test that in here, but also if I use it, then it's going to @ somebody. So I'm just going to use myself so that I don't accidentally @ somebody I don't intend to. So we do something like thanks to, or whatever, right? And then we could also add a thing like breaking. So breaking is a keyword, typically in all caps, that you see when you're trying to indicate that a change that you made is going to make it so that if people upgrade to whatever version now will contain this change that you made, something is reverse incompatible. Something is not going to work anymore. So by indicating that, then it helps to make sure that when people are looking through your change logs, or even better, when you're doing automatic versioning, that you can now indicate both in an automatic way and in a verbal way that somebody should be really careful when they're going to update. What else can we try? Let's try, because I think one of the changes I want to make in this system is in having. I want to be able to have markdown in these things, which isn't against the rules specifically or anything like that. I want to be able to have markdown in these things, and there are some other aspects of conventional changelog and of also just conventions around Git messages that limit just how much we can do. So a normal Git message is supposed to just be one line, right? It's got one line, a body, which could be a whole bunch of paragraphs separated by new lines or whatever, and then an optional footer, which is just basically if there's two bodies that are separated by new lines, then one's called the footer and one's called the body. That's just by convention, because an actual Git message is just a bunch of text. Doesn't matter what it is. But there are some features in Git and in GitHub and in other tools and services that take advantage of various conventions. So having all this in one commit, for example, means that you won't see this. Like, even though this is a change, you won't see this if you do a normal git log, or if you do a git log one line or whatever, because it just shows your first line. There may be some things where you're trying to search for something that only search the first line and don't search the rest. The main one is about visibility. Like, not all this other stuff will show up. And then because they have this idea of, like, I've got the title about the thing and then the explanation for the thing, then these things are all assumed to be connected. And if I wanted to make it so that sometimes, so it's not, say I'm converting this thing into an actual changelog, into a patch note, then maybe much of the time I don't actually want to show the body, right? I just want to show the headline. But maybe sometimes I do, right? So how do what feature set do we need to allow for that? So we're not going to deal with that now. It's just something to be thinking about. Is there's all kinds of ways that this could be done. I think this is probably a good enough start for the moment. Gets us a whole bunch of the components that we need and hits kind of the major features that we know that we want. Oh yeah, the last one I did want to have, though, is the idea of tags. So this is based off of first conventional changelog, which is exactly what this format is. So both of these, or all three of these, I guess, are adhering to the standard conventional changelog format. This one starts to deviate because I have this whole like something pipe something else. A nice thing to do would be for me to have an alternative syntax, because we'll need this for our existing changelogs because they all use this, or our existing Git messages, because they already use this. So for backwards compatibility, if I do switch to this new tool, then that has to still work. But what I would like to do is actually change it to a new syntax so that people writing messages using this system will have full compatibility with conventional changelog, including ourselves. That way it's easier to convert back and forth, which means that ideally I would leave this syntax intact and just add on additional stuff that won't mess with that syntax. So I think what I'd like to do is now take this idea of a stream and change it to an idea of tags instead. And so then that could look something like, we'll keep the pub in there just because we should be able to use both at once, so that should be fine. We'll make a new topic here, so we'll call this what? We'll call this for change logs, so we'll call this formatting or something. Then we'll say add an HTML output option or whatever. So then the idea here could be that we could add some tags to this thing. So we could say there'd be a bunch of ways to do it. We just need something we can easily parse out that isn't likely to conflict with other things. So the problem with a pound sign is that it's used by so many other things to try to parse information out. So it's used by, like I said, GitHub will look for pound followed by a number and then the word closed or closes in front of that to decide if it's going to close a pull request or an issue. But it specifically looks for numbers though. It looks for slash, looks for digits. So if as long as the tags that we're using aren't numbers, then there won't be any confusion there. Similar, if I don't put anything in front of it, like the word closes or something like that, then that's also fine. But another alternative is I could just use the keyword tags, right? And I could just put those in though, put those in there. See here, I could have tags, dev, private, or whatever. So that's one optional way to do the syntax. It could just be that I just skip that part and just use that. Yeah, there are a lot of options here, and it's not clear what a good one is, so we'll just choose something for now, and then we can kind of see if they play well with things. But for now, we'll do that. All right, everybody, how's my handful of viewers? How are you holding up with this deep dive into very specific stuff? Oh, just checking the chat while I drink a little water. No one's got any comments. That's fine. I get it. So then let's do our set up our tests here. So we got our sample code here, and now we just have to know what are we trying to accomplish. What can we do? So what we want to be able to do first is make sure that we can actually break this thing apart, right? So probably what we should say is it can identify whatever we'll call this. We'll call this because this is actually conventional changelog format, right? It can identify conventional changelog formatted messages. Yeah, I can do that. We'll say. So we're kind of doing a lot of things at once because the code that we're going to use is going to do kind of all of this. And make it into smaller parts we can write unit tests for, but it's going to be doing a lot of stuff out of the gate. So the way that Mocha works is, again, you're basically registering some test that's going to happen here. So here we're registering a set of tests. So we call it that. We give this function. That function gets called, and then it goes through, does its stuff. So it basically sets up environment things, and then finally it'll call something. So it's going to register these tests. So now we just have to do something here. And the idea is this thing has to get converted into some sort of data structure, right? So we need to invent that. Then we need to see if the stuff that comes out of here actually matches that. Let's see, Matitanscain, I think, something like that. Matt Titanscain says interesting stuff. Getting a bit too late in Europe. Yeah, I get it. It's Sunday. Depending on time zone, it might be late. So you do your thing. Take care of yourself. Thanks for popping by. Okay, so we could do this the proper way, which would be to say, okay, what are input-output things? Let's construct all of that and do all that. Or we can just get right into some code, which seems like, at this point, the more fun thing to do. So let's make a class here that we'll just call. We'll call this message. So the message class, message, is going to, this is basically going to take into its constructor the string. It's going to take a string in, and then it's going to parse it. So I like to wrap these things in classes because then I can add utility functions that do all kinds of fun stuff, whether it's mutating things or converting things to some other format or whatever, and that way it all is happening automatically with code and all centralized in one place. This is what we do here. So this is going to say the message class takes a full get message in its constructor and parses it into patchnotes compatible data structure. Constructor. So here we'll just call this thing message lowercase. That's fine. We could over time feed options to this thing, but we would just take it one step at a time. Some people don't like the class, the class syntactic sugar in JavaScript. TypeScript uses the same thing. It has TypeScript adds some extra features on top that again compile down into JavaScript. Technically, JavaScript doesn't have classes. I'm not sure why people obsess about that fact though, because it has things that behave enough like classes that it's really useful. And so, who cares, you know? We have this nice feature here that we can use called where TypeScript gives us these keywords like read-only and private and protected, things that if you're familiar with object-oriented programming would be fairly unsurprising. And you have a few options of how you would specify those. So you can basically, in kind of your preamble, you can declare these things where you could say, I have a read-only property called message, which is a string. And so now here I've declared that this thing is going to exist. So this is upset because I did it twice. Or actually it's upset because it hasn't been defined yet. Now with TypeScript, I can do a few fun things. I can say, oh, actually, this isn't necessarily defined. So by putting that question mark there, then, so the colon means that it's the type of this thing is a string. I can then say this is equal to something by default. Not minus nothing, doesn't make any sense. So this would be like a full syntax deal here for TypeScript as a class. Is I'm basically saying, okay, this thing is read-only. It's got a property called message that is read-only that is a string. This is the colon string, and by default it's equal to the text something. And I can then override it in here and do other stuff with it. Then there are some various shorthand versions of that. So if I just do this, then this is me saying this thing has a thing called message. It is a string, but I'm not setting a default value. Now this thing is upset because I have to set, until I set this thing in the constructor, then I'm basically lying, right? Because this thing doesn't have a field called message that is a string because I haven't actually set that. Unless I say that it could be undefined. So I can do that in two ways. One is like this, in which case, so that in TypeScript this means this is called a union type, where the type is either string or undefined. And now I'm not lying anymore because I said this thing has a field called message that may be undefined and I didn't define it. So it's not a lie. And then finally, I can say that this thing may or may not have a field called message, which is not quite the same as it has a field called message that might be undefined. Here I'm saying it may or may not have a field called message. The sort of practical outcome is identical. It's just sort of slightly conceptually different. And the shorthand is a little nicer. So here I'm saying this thing may have a message, and if it does, it's called, or it is of type string. Here though, I want that to be required. And there's a further shorthand for this, which my constructor is the arguments that get passed in when I create an instance of this class. So if I were to do a const my message equals new message, so that you can see it auto-populates, it tells me that that my first argument is this thing called message that's supposed to be a string, and that it returns an instance of type message. So that's what all this stuff that you're seeing here means. And so then here, if I were to pass hello as my message body, then you can see nothing is happening here, right? But that's what the constructor is doing. So I have the shorthand that TypeScript gives you, where I can, if I use one of these keywords like private, public, read-only, protected, whatever, if I use those in this context in the constructor, then it knows that I mean for that to be an instance property, and therefore I can skip the whole declaration part. So this is nice when you're going to have a constructor that just directly takes arguments and just stores them in the instance without you mutating them or doing anything else to them. So we're going to do that. That way we have like the raw message, right? Which is that thing. And we're read-only, that way in the code we're not able to change it to something else in the future. So a thing to be aware of with TypeScript is that many of these things, like the private keyword, the read-only keyword, all this kind of stuff, they don't do anything, right? They basically are making it so that if you break that promise you've made that this thing is supposed to be read-only in your code by trying to set it somewhere or something, or if it's private, trying to access it somewhere, then Typescript will give you an error. But that still might be valid JavaScript, because there are ways to make things read-only in JavaScript, but me just saying this thing is read-only doesn't guarantee that Typescript is going to do that. So that's kind of a FYI thing. Be careful with your assumptions about how safe things are. They're very safe in your static code when you write this stuff this way, but that doesn't necessarily mean that you're guaranteeing that stuff can't happen with the compiled code. Because, again, regular JavaScript does have ways of making things read-only. It does have ways of making things private. It has mechanisms for these things, but that doesn't mean TypeScript is actually utilizing them in the background. All right, so we're going to take a message and we're going to compile it, or we're going to parse it to try to learn some stuff about it. All right, here we go. Let's get rid of that. So what is that going to look like? That's the question. We got our sample over here. Here's our sample message. It's going to look like this. We're going to have these sections that basically consist of this pattern where we have one of these keywords that starts at the beginning of the line, followed by optionally with something in parens, followed by a colon, and then followed by a message body, and followed by a message. And that message could consist of any number of lines separated by a single new line. And then that makes up the message, right? And then what we want to add here also is the ability to have a body. So then this would be the body for this message. So that needs to be, basically we then discover that this thing exists. And then we check the next one and see if that also starts with this pattern, with a pattern like this, because if it does, then that's now a new message. If it doesn't, then that's a body for the current message, if that kind of makes sense. And so we need to be able to kind of work our way down from top to bottom to identify all these components and then break this originally one message up into multiple messages. So that's what we should say here is actually we'll just call this can parse, because then we can just check everything inside of here. Can parse a complex commit message. Why is it giving me errors? Oh, because I'm not using this and because this is empty. That's fine. So VSCode gives you a little error summary up here. It says it's got 2 errors. That's fine. We don't care about those right now. Okay, so let's do it. So we'll make a private function just to separate things out, keep it clean. That will call parse. And then here, actually, I'll make this static. That's even better. I'll make a static message called static parse message string. So that way, this thing actually could be used by other stuff, not just this thing, if we for some reason wanted to. So classes are also a nice way to kind of bundle things together, even if they are not necessarily strictly conceptually related. There's, of course, whole theories and practices and best practices and worst practices about object-oriented programming. Most of them don't hold up to real life once you start doing complicated things that well. Some of them do, but this is all just a matter of, use the tools that you know, and you do what's convenient, and then you just refactor as necessary. And as you learn new things, you look back at your old code and you think, oh, that was a terrible design pattern I used there. And that's fine. You fix it. It's no big deal. So instead of worrying about doing it right, you just think ahead a little bit and ask, oh, this is probably a little more convenient, and then do that, and then it'll probably be fine. So how's it going to work? We need a regex that's going to match that pattern, and we need to start at the top and work our way down. So here's how that can work in JavaScript. So in JavaScript, regexes can be made as, regexes are objects, and they can actually keep track of where they last found a match, allowing you to sort of go over a loop and use the same regex and then keep on moving forward, right? So we want to take advantage of that fact. So we'll call this thing conventional format regex. right, and now if you're not familiar with regex, this is going to get hairy very fast. Hairy in the... Actually, I don't even know why we use the word to mean that, but anyway. Here we go. So a caret means different things depending on where it is in the regex. If it's the first thing in the regex, it means the beginning of the line. So that's what's happening here. $sign means end of the line. That's all that is. So for the moment, we'll not worry about that because it's going to be slightly more complicated. So what we're going to do is we're going to say we're looking for the beginning of a line. In this case, not the beginning of the string, but actually of a line within the string. Now we're going to look for that syntax, which is going to consist of some sort of a word without any spaces. So like this, right? Some sort of a word without any spaces, all lowercase. So the more constraints that we put on this, the better, because if we have too few constraints, then it will start getting false positives where somebody just wanted to have a word followed by a colon with some stuff and they didn't intend it to show up as this kind of a thing. And then now all of a sudden it's really weird. There are some ways we can handle that. One is just to be really limiting one is to just be as constrained as we can while still allowing a lot of flexibility. So in this case saying, well, any all lowercase word with no spaces and so on, followed immediately by a colon with, again, optional parens in the middle, is good enough that we'll call that fine. If we wanted to constrain it further, we could require some sort of a configuration option here where we could whitelist what the allowed names are, so that it would basically still find those patterns, but then just skip them. But it's still unclear what we should do in that case, because if we then find a pattern that looks like it but doesn't have one of those keywords, does that mean it's something we want to ignore, or does that mean it's part of the body of the prior one, right? It's unclear. So we're not going to worry about that kind of question right now. Instead, we're just going to do this. So at the beginning of the line, we're going to look for some sequence of letters. For let's say no numbers, just letters. We can have, let's say we need at least 3. So this means in regex terms, this means beginning of the line. This part means any letter A through Z, but it's matching it one time. So it's not matching like all of those, it's only matching a character. It's basically saying beginning of the line matching one character, that is any character between A and Z inclusive. And then here is now the number of times we want that thing to match. So we're saying we need that at least 3 times. So this will prevent us from having like a colon or whatever at the beginning. So again, adding these kinds of constraints, we might want to have also an upper end to prevent other kinds of surprises from happening. So if we look at our things we have in here, performance is our longest word, which is how long is that? 11 characters. So we could be still fairly liberal here and say like 16. And I've got just a really simple basic filter that prevents particularly bizarre things from happening without setting any really strong rules. All right, beginning of the line, lowercase A through Z letters 3 or more times, and then followed by a colon, some number of spaces, and we could allow optionally, so actually we could allow spaces before and after if we wanted to allow some flexibility in parsing so that people could make minor mistakes and it's no big deal. So we'll do that. There's also no reason you would have to have a space on either side, so we'll also allow that to be optional. I don't know if conventional commits require that, because if they do, then that means you can make commits here that are not compatible with conventional changelog. I'm not too worried about that though. I just want to make it so that you can make commits that work with both, but not that you have to. Okay, so any number of spaces, and then followed by just other stuff, right? So followed by other stuff, although here we won't worry about that yet. That's all we're going to do. Okay, so now the part we're missing is, let's see, why is that star? Yeah, that's okay. All right, I think this is okay. So the part we're missing here is the optional topic, right? So that's going to be this thing. But in regexes, parens are for grouping things, and so they have a functionality. So we need to escape that functionality by putting a slash in front of them. This is a lot of why regexes get so hard to read so fast, is because of all like the escaping of things that you're doing. And it very quickly becomes hard to tell what the hell you're looking at. So if it's looking weird, that's okay. And if you have questions about regex as we're doing it, pop them into the chat. So we got this, and then this could now again match basically anything. Like anything could go in here, right? So we want to again set some limits on the kinds of stuff that can show up in here, so that this doesn't just go on forever. The idea of that section is that this is supposed to be sort of like a category, you know. There's no reason that category couldn't have spaces in it, right? So it could be any of a number of things. And so it's not obvious what we should do to limit it. So I think probably what I'm going to do here is just say that there can't be another like set of parens in here is one option, or we could say we allow like alphanumeric characters and spaces, or there's a whole bunch of stuff that we could do to limit it, but it's not super obvious what we should do. So what I'm going to do here is say it's basically just allowed to be anything. Actually, we'll just say anything except for a right paren, and there should be at least one thing in there, or there should be at least one character in there, right? So basically anything that isn't a paren, then we'll call that fine. And then to make this part optional, we just put a question mark there. So this optional thing, oops, sorry, we grab this whole thing, surround that in parens, functional ones that aren't escaped, slap the question mark in there. That means that this group, because the question mark refers to whatever the prior thing was. The prior thing here is this group. And so that means match 0 or 1 times is what the question mark does. So that's, in other words, it makes it optional. So this thing has become optional, and then if we match it, it'll basically match anything between 2 parens that isn't another paren. But then when you take this one step further, because we still have this syntax that is from the way that we currently manage our messages, is this idea of a stream, which I'm going to change into the idea of a tag, so we can have multiple of it. But in that old model, you can only have one of these, so that way I can just treat that as legacy, treat this basically as a tag. And then this also has always had really strict things, because it can just be ASCII characters, and that's it. So then what we can do, finally, is check for, so here we're now inside this inner group, right? So we got a paren, a left paren, and a right paren. Then anything that isn't a paren is now the name of the thing. So what we can do here is now add another group that's also optional, and this is now going to be that tag. So we'll put a pipe here. So pipe is also a special character in regex, so we're going to escape it. Right, so it's going to be hard to read, but that's what's happening. And then we're going to have, so it's something up to a pipe, but it can just only be characters. A through Z, 0 through 9. And then this would have to match for, you know, I guess it could match 0 times if you just had a pipe in there and then it didn't do anything. We would just then ignore in that case. So star for any number of times. Okay. So if anybody's watching, how confused are you? Does that track? Do you like regexes? Is this just confusing? To recap, beginning of a line, any letter, lowercase letter, 3 to 16 times. That's now like the feet or fix or whatever. Optionally, followed by this thing. Barely a coder says that regex stuff looks like a good password. You are not wrong. You are not wrong about that at all. It'd be hard to type though, but you should use a password manager anyway. So we got this thing, which is this is our optional group that's specifying the stream, and I guess optionally the stream, and optionally the topic. So collectively that should work. We're going to now, Bryce Taylor says, spent some time writing regex land. It's good to brush up. Yeah, I don't even know what I would do without regexes. I use them literally daily, and they've saved my life so many times. But they take some learning, and they take some practice reading. That's for sure. So the final thing I want to do here before we start like testing and playing with it. It is kind of dangerous to write a full-on complex regex like this without testing its pieces, but it's easy enough to break it apart if it doesn't work out of the gate. So the final step I want to do here is add the. There's an npm module called xregexp that is the documentation is a little hard to figure out because it feels like it's not thorough, but it allows for you to do all kinds of complex weird stuff to regexes, like take 5 and stick them together and that kind of stuff. So this is a good kind of case where such a thing could be very useful, where you've got a complex one like this doing a bunch of stuff that you might want to break into some shorter ones that are easier to test and describe. But I think we're okay here. So now I'm going to do is add some more capture groups. So a group is a thing you can capture and then refer back to. And I want to be able to do it by name. So this is the syntax for that. So then we'll call this this is the type, probably. Actually, let's look at conventional changelog. Conventional changelog. Yeah, they call it type and then scope and then description. So we'll just follow that same parameter. So type. Now what this does is, so I've added this capture group, right? So this is basically saying treat this, the stuff in here, treat this first match as kind of one unit that we can then refer to in some way. And then here I'm giving it a name so that I can refer to it specifically when I actually get a match from this thing, that I can pull it out. It makes it a lot easier to parse these things, because otherwise you do it by position, where you're like, I want the first group or the second group or whatever, and that gets hard to keep track of, because look at all these parens, it gets really hard to keep track of. And of course, if you then change something by adding another group, now all of your indexes are messed up. So having named capture groups is really useful. This has been available in JavaScript since ES6, which was like 2016 or something like that, or earlier, even 2015 maybe. Okay, so I got that match, and now we have this next group. So this is a whole group right here, but we only want the pieces of it, right? So we have this first optional bit right here. So yeah, so this first optional bit right here, which is the tag, right? But it's the tag followed by a pipe, and we don't care about the pipe. So what we're going to do here is actually add another group. Again, this is why this stuff starts to become very hard to read very quickly. Another group we're going to call this one. This is also why doing it by index instead of by name is horrifying. So now this thing is going to be called the tag. We don't care about the pipe, so we can just not worry about that. And what we could do is allow for more spaces in here. So we might come back and allow for spaces to exist, but we'll do the rest of it first, because the more characters we have, the harder it is to read this thing. All right, so now we have this optional thing. We can pull the tag out, and then we have, after the optional thing, which just ends at the pipe, if there was one at all, then we have the actual scope as is referred to in conventional changelogs. So that's this part. So now we can call this thing the scope. So that kind of track, I feel like that makes sense. So then we got the scope, and the rest of it, the stuff that happens after this, is now the description, which we're going to handle parsing of that slightly differently. The idea with this thing is to get us to each subsequent section, basically, of a single commit. All right, now finally, I'm going to add. Actually, so we can test this one specifically. So we can write a unit test for this. That'll be good. So then we can actually, I'll do that before I add anything else to it, so just in case it's not working. So here I'm going to stick an X in front of this. This tells. So this in Mocha basically says to ignore. So xit just says like skip this test for now. So this is a really easy way to very quickly just like skip some tests for some reason, but it still logs. It logs it as a skipped test, so you can still see it show up in your results. Here you can see I've got this ESLint rule that says no empty functions, which is annoying because I don't want to see this as an error. So I'm going to turn that thing off. I think probably the way to do it here is to use quick fix and say disable it for this line, because I can copy this message here. It's harder to copy that little pop-up for whatever reason. ESLint RC YAML. All right, so we're going to turn this rule off. Actually, it's going to be a key. It's a key, and then this is going to be, oh yeah, since this has an at, this doesn't obey YAML, so I have to put quotes around that. That's fine. Turn that thing off. And then now that error's gone. Beautiful. So what we're going to do first here is it can, actually it still is what we're doing though, isn't it? It still is what we're doing. That's fine. We'll just use it to test, this parser. So hopefully since I'm exporting that thing, that TypeScript is already aware of it, so then I can say const message equals new message, autocomplete in there, it auto imports for me because VSCode plus TypeScript is great. New message, I'm going to grab this thing which is called, just call it message. Ooh, that's bad, this is a shadowing, we don't want to do that. We'll call this thing sample message, so we don't have any scope shadowing. There we go. Only replace the whole thing instead of sticking in the middle. Okay, and then what we can do here is, so at the moment this isn't actually doing anything, right? So it's just storing that message and that's it. So we won't test that part yet. We'll just test, actually no, we don't even need that because this is a static. So we'll do const parsed equals message dot parse sample message. There we go. There we go. And for the moment, we'll just log it so we can see what's coming out of here as we kind of figure it out. All right, so here then we're making this this regex, and so we could also store this regex separately and then just refer to it in here, which probably would make sense. So we can do that as another static if we wanted to, as a static getter, or we could do it just completely externally. But I'll do it. Well, no, we'll do it internally, because if you expose something, that you should have some obvious use for it, and you want to annotate it and stuff. So we'll just not expose it for now. Can always make it available later if we want to. So we'll pull this out of here. There we go. So now we can do here, just for the moment, is just return the conventional changelog for regex.exec. There are many ways to run a regex against a string in JavaScript. The reason I'm using exec is because this is now running on the regex itself, and this is what allows us to have the regex, because it is an object, keep track of its own, which actually, that's exactly the reason why I wouldn't do any one of these each time. It's because it's an instance that we need to track data on. Anyway, so it'll allow this thing to keep track of where the last match was, so we can now match multiple times across the thing. You can do it the other way around, where you can take a string and call the .match function, and then pass a regex to it, and it'll basically use that regex against that string, and you can use that to also like find every match in a thing, but now it's going to, instead of finding it as a bunch of returned regex results, it's going to give you a whole bunch of strings, like the string components that matched. So this way it works really nicely if you want to work your way through something and continuously kind of move the index position of where you're looking for stuff. Then starting with a regex and then executing searches on it so that you can store stuff is really useful. So we're going to try that, see what happens. So we're going to just parse it, log it, that's all that's going to happen. So now we have to be able to run tests, right? So that's what we have to do next. Let's go into, there are lots of ways to do testing until we want to do some live debugging and set breakpoints and stuff, which we will probably do later. Until we get there, we'll just do it the simple way, where we just run the test suite, and that's it. So here you can see I'm just exiting if I try to run tests, so we need to actually add this in here. There are lots of ways to cause tests to run. We just want to do it in a way that's convenient, and that works every time, and it keeps us out of trouble. So I'm going to add a build script in here that just runs TSC. That's a TypeScript compiler, so it'll compile our project. I'm going to add a test, actually a test script. Now have a test script. And so what this thing will do is npm run build. That way we guarantee that we have compiled everything before we try to run a test. So that way you don't find yourself changing things and then running the test and then being like, why didn't that change, right? And then going down the wrong path to try to track down a bug because it turned out you did fix it, but didn't recompile to discover that you fixed it. So run build, and then we will npm, or then we will run mocha, which, because all of our test code is in TypeScript here, right? Then the compiler, the TSC, is going to dump the compiled versions of those same tests into this build folder. So that's where we're going to be running our tests. Build/test. Yeah, build/test. And that's it. Easy peasy. So now I can, in the console, run npm run build, because I'll run this script, which just runs TSC. I could have just as easily ran npx tsc, because that's all it's doing, but we want to add features to it later. So that's that. This should, in theory, be up to date. What do we put in here? Put this thing in here. So yep, there's all that stuff. So here's our compiled JavaScript, which looks a lot like our TypeScript, but you can see all the types have been removed, which is exactly what you'd expect. It's referring to these source maps and things, which is all part of what we set up in the TypeScript compiler. So we have, this is mostly for debugging. Then we have the types themselves that are put out as a separate file. So here you can see this is a .d.ts is a declaration file in TypeScript. And so this is basically saying, hey, this thing is a type that exists, but that's now handled separately from the JavaScript, since JavaScript can handle types. That way, when you have tools that understand TypeScript, that run JavaScript, you can actually use both at the same time. So that's all working great. And then, so we know that that's running, and then we also know that we can run tests. Another thing that I like to do here is, before I build, is do an rm-rf for the build folder. And the reason for that is because otherwise you may end up with some leftover scripts and things that got compiled, but then whose source just got removed, but the compiled code is still there, and you could discover some pretty weird things happen as a consequence. Because something might work, but it only works because it has some dependency that it isn't even supposed to have anymore that you didn't know was there. And then when you finally do a build without, like I do a fresh build, all of a sudden things don't work again. So this is a nice way to prevent that. Cool. So we got that. We got that. Yeah, so now I can just run the test and see what it looks like. npm run test. Npm test also works. It works the other way. There are a few of the built-ins you can use without the run subcommand. So you can see it's just doing what I told it to. It's doing that, so it's doing the RF first. So now here this is upset. Here this is upset, right. So this is upset because I'm using modules, but I didn't do a full path here. So that'll fix that. So this is the difference between CommonJS and ESM, like ECMAScript modules, is that ESM requires a full path for your local stuff. For imported things for Node, as long as we have that Node resolution, Node module resolution set, then that still should work. Let's see if I'm right, see if that's true. I've done so much debugging of CommonJS versus ESM stuff that it's become old hat. Spectacular. So, here's what we got. We parsed this sample message, and then we logged what we got. The result is the output of a regex match. It's called a regex match. I guess the type is a regex match, or match array, or whatever. So the first part is basically the whole match, and then after that, it is each subsequent match group as an index position. So like just basically where the left parentheses are for each group. So your first, second, third, and so on. Then this would be the content that was found in each one of those groups. So index is the leftmost position of the whole match, and then it gives you your input back, which is just what we put in there in the first place, and then groups, or we put those named groups in there, and then it gives you that as an object with each name as a key, so you can just pull the items out that you matched. Now what you can see here is that this didn't work. Well, it partly worked. Didn't work enough. What this should have given us was, and at the moment we're not doing a multi-match, we're just matching the first thing. So at the moment, it should have given us this, right? And it did. It gave us that match file, right? So it identified this part. Actually, no, sorry, this did work. This did work, because this one we're not actually matching the description yet. Since we're not matching the description, we're only matching this part. Then this one is correct, right? Because this is the whole match, but the only parts we care about. So it's basically stripping everything else, and so it's leaving us at the description. And then we end up with the type, which is feet, and then nothing else is populated, which is exactly what we expect. So that's perfect. So the next move now is to make it so that this thing will keep on running and looking for subsequent matches, so that we can then see that each match works the way we expect and that each thing is parsed correctly. And then from there, we populate the middle content, the actual descriptions of things. So let us do this. Let us do this. All right, so like I said, this exec function applies to the instance of this regex itself, and it basically increments a field called last index, I think, to the last position you went to, if this thing is global. So we actually put the G flag on here to say that this is a global regex and we're looking everywhere. And if we do that, then it'll allow us to do this tracking. So what we can do here is we can say while true, put ourselves just in an ever increasing list. Then we're going to check for a match. So we can say, actually, sorry here. So we can say while true, we're going to look for a match. Const matching line, or matching. Here's what we'll call this. We'll call this preamble. No, prefix. No, start of the line match. Indicator. We'll call this indicator. Or indicator match. It's like indicating that that part of the line is format match. There we go. That's better. Maybe. It's hard to name things though. So then this thing is going to look for a match, and if it doesn't find one, if not format match, then we'll break. So that way we don't get stuck in our loop forever. But because this thing has that global flag, we're using exec, then every time it finds a match, it moves the index position, starts searching the next spot. And then so if there is no match found, which will happen eventually if we get to the end of it, then this will become null, and then this thing will end. So with this pattern here, we're guaranteeing that we're not stuck in this loop forever. It looks like we have an ESLint rule called no constant condition, which is a good rule of thumb. You know, it's dangerous to just have a while loop that will always run unless you break it. But here we know we're doing fine, and I don't like that rule anyway. So I'm going to disable it so I can get its rule. Then we can go get rid of that. With all these rules, it's always, you know, it's that convenience versus safety, just like with passwords and stuff, right? And you get to choose where you want to inhabit that world. Okay, so now if I'm not matching format, then I break, and otherwise, now I've got this thing that I can parse. That's got these groups on it with all these different names. So what I can do here then is create an object that has those fields in it. And actually, really, I just want that object. So what I should do here probably is create a type here that matches this. So we're going to create a type called interface. So in TypeScript, you have interfaces and types. They're similar. The general rule of thumb is to use interfaces unless you need to type. So that's fine. It wouldn't make that much of a difference in most cases either way. So we'll call this thing it's a conventional format badge. So this thing has those fields. It's got a guaranteed type field, which is a string, and it's got a optional tag field, which is also a string if it exists, and we've got a optional scope field, which is also a string if it exists. So you also notice with my Prettier formatter, when I saved, it converted all my commas to semicolons. Both of those technically work and are valid TypeScript, but the nice thing about the semicolon is it kind of helps you not think about this thing as an object, but as an interface. But both are valid. So those are my components. And we're going to add more to this because this is going to also include the description and anything else we want to parse out of it. But that's all we got for now. So we got this format match. Then down here we can say const. So now if this thing matched, that means we have those parts that we care about. So what we can do here is just start storing them as we go. So we can have this thing be let's see, how do we do this? What are we doing here? Let me close that and that for the moment. Right, we're pulling the messages out. Yeah, we're going to keep track of these. Okay, so const logs, I guess, or notes, patch notes, messages. Yeah, right, this is, yeah, we're going to want to refactor this probably. We'll get there later. So we'll say format matches. And the type of this thing is going to be an array of these. Set it equal to an empty array, so that it's initialized. I'm basically going to populate it. So I'm going to do format matches dot push, and then so this match right here, this is a regex exec array, which is not exactly an array, it's an array-like thing. So we're going to push that thing on here, basically. We're going to specifically grab a subfield, which is that groups field that you saw down here, this thing, right? Because this groups field is this thing, right? Format match dot groups. And so here, now TypeScript doesn't like this because it doesn't know what groups is. It doesn't even know if it exists, right? So here it says type undefined, is not assignable to string. It has a generic type, which is just key of string, value of string, right? Which then does technically match this type, but because it can also be undefined, that it doesn't. So there are two ways to resolve that. One is to do this. Oh wait, I can undo that there. Oh yeah, so here, if I do an exclamation mark in TypeScript, like before a dot accessor, then that means that the thing before it, I'm insisting exists. They don't have an equivalent for the last one though, so I can't just put like an exclamation mark there and say that thing does exist, which is kind of a bummer. But what I can do instead is say as, which is a TypeScript thing. I can say this thing as conventional format, which I should be able to. So I'm assignable to type string. Groups as conventional format match. Why is that unhappy? Why is that unhappy? Const message parts is equal to. This thing should work. This thing should work, and it doesn't. Key string. Property type is missing. Oh, yeah. Okay, right. Because the baseline type that this thing doesn't have this required type field in here. Okay, so that's fine. We know that we're doing this right, so we're going to do a trick that you use in TypeScript if you know that you are absolutely correct, even when you're trying to do things that TypeScript says are incompatible, which is this is called a type assertion, where you basically assert that this thing is like this is just an unknown now. As soon as it's unknown, it can be anything. But unknown is treated by TypeScript as also invalid, and it doesn't let you do anything with it. So we can convert it to an unknown, or we can assert it's an unknown. It's different than a conversion, right? Because none of this is real. It's all just us claiming things. So we assert that this is unknown, and then reassert that this unknown thing is actually of this format. Okay. So that allows us to have this thing show up as the type we want it to be. We know this is true because this thing had to match and so on. There are these kinds of cases in TypeScript where it's being very protective of you, and if you dig into the details a bit, then you'll discover that it actually does make sense and that you're glad that it does it that way. But in some moments, it can be very aggravating. But here, it's fine. We got what we wanted. So now we can pop this whole thing back down here. Have that be that. So now what should happen? Wait, what is this upset again? Fine. Let's do that. Now it's okay. So format matches. Oh yeah, duh. This is the problem because it's the wrong stupid variable. There we go. Right, I didn't like this. Oops, there we go. There we go. Right, now we're gonna return this thing. Format matches. All right. So now if we rerun this test, we should now see, hopefully if it worked, we should see all of our messages fully parsed. It'll be very verbose because it's going to be those full matches. We only saw one though, huh? We only saw one. We only saw one. So that means one of two things. Either that the rest of this regex doesn't match everything, or we just did something wrong here so that it's not properly moving on to the next one. So a way to test for that would be to... So this one definitely should have shown up, one would think. One would think. So let's log this thing. And then we gotta figure out why. So basically each time this thing runs, we should also be able to see console.log format match.index, or not format match, sorry, conventional change conventional format regex.index, last index, yeah. Found at. So this is one of those good places where if we were actually turning on the debugger, this would be nice. The debugger is a little tricky because the debugger is running in the raw JavaScript that got compiled, but we need it to trace back to our TypeScript. So there's a way to do it. It's not that big of a deal, but it's just enough of an annoyance that I'm not ready to do it yet. Okay, so you can see this was working, right? It got to our next thing. It got to that position. It found that. So my current best guess here is that, because this definitely should have matched, because it's exactly the same as this. So my best guess here is that this is a multi-line match kind of a problem, where it's treating the asterisk as the whole string. We want to have it treated as the start of a line. So I think M is the flag for that. So let's see if that's true. Or will it be a trickier problem? Debugging regexes is always something. Hey, that was it. Beautiful. So to recap, G means global, means find every instance of this thing. In this context for this regex, that since we're execing on a regex, that means that, or I guess the behavior of that is that it increments this last index parameter each time it finds a match. We can also, this is writable, so we could also just set that if we wanted to. And then the next time it runs exec, it runs starting from that position. You'll notice that even though that's being stored here on this regex, we could in principle pass a completely different string each time. So we could run exec, pass a different string in, and now really weird stuff is going to happen because we're going to be incrementing an index using the prior string, and then surprises, right? So this is kind of an unfortunate, hidden, surprising behavior of JavaScript. It's very useful, but it can definitely get you in trouble. And then that M means multi-line, so that says to to treat the dollar, or sorry, treat the caret not as matching the beginning of the whole string, but as matching the beginning of a line, and to not use dots as matching new lines and a whole bunch of it does a whole bunch of things that collectively mean you can match one line at a time. Great. So now if we look through here, let's see this match things the way we expected it to. So going back to our sample code, we've got the first one should be feet, which it is, and there's nothing else in there. The second one should be chore, which it is, nothing else in there. Next one should be docs, which it is, and it has this scope called dev. It's got that too. Then we got another one called fix, which is down here, and it's got a type of fix, it's got a tag of pub, and it's got a scope of dev, so that worked great. And then finally we got pub and format, which we also got feet pub format. So this works. That's a good deal. Got it in one shot with that regex, which is not always an easy thing to pull off. Cool. Okay, so we do that, and then the question is, how do we, once we've found one of these, how do we get the stuff in between, right? So there are a bunch of options here. I think probably the way to do it, and also these cases where it's like we've got one message that actually is broken up into two lines, but there's only one new line in between instead of two, right? So how do we find all of these cases? We could try to construct a regex so that it continues matching, but only will match, one new line at a time. But it starts to get pretty complicated. But you'll notice that we've been able to skip through this whole thing in like one go and find the locations of each of the sections, which means we could break it up pretty easily by just storing those indexes. And once we've broken it up, then the stuff that we have left is now already complete, basically, and we can just do some simpler parsing on that. So that would be the way to do it, probably. Glusgap says, thanks for doing this. You explain things in great detail. Yeah, I'm glad that you're enjoying it. This is the kind of stuff that I love talking about the stuff and teaching it, but it's hard to find people who want to know about regexes, Probably somebody in here is tired of me explaining all this stuff over and over again, but I figure that's how you learn, just hearing things lots of times. Again, if you have any specific questions about regexes or JavaScript or whatever as we're doing it, just hit me. I'm here. I'm basically doing this for fun with the side effect, hopefully, of having a nice little project afterwards. All right, so push another thing on there. We've got all these matches. So now let's go to the next step. I think I like this idea of doing this in two passes. One pass where we identify all those things that match that syntax, match that format, and figure out where they are. And then a second pass where we now go through each of those sections and then pull the parts out of those sections. So let's do it that way. So the way that would make sense here would be, we already have the index on here anyway, so let's just add that to our interface here. So we'll call this yeah, because this is a little weird, right? Because the question of what's a message? Because in this case, I was thinking about a get message, right? But the get message has multiple messages in it, right? So it's a little unclear how we want to actually refer to this thing. Actually, that's how we should break it up. Yeah, probably what we actually have here is a get message, which is one class. And then inside of that, we actually have our sort of patch note messages, right? So our messages, which would then be not a subclass, but a class we store instances of inside of that. So that's probably the thing to refactor this to at some point. Not this exact moment necessarily, but soon. Actually, yeah, let's just do that. Let's call this thing get message body, get message body, get message. Let's call it get message. That's fine. Let's get message. Oh yeah, in VS Code, especially if you have TypeScript, because it's a feature that TypeScript allows. If you are in JavaScript or TypeScript and you hit F2 when you select a thing, it pops up a little editor right there. And if you edit it there, it does global rename of every reference of that, but it does it correctly. So if I have another thing somewhere else called getMessage with the same capitalization, if it's not the same thing, just happens to have the same name, then it won't get replaced, which is very handy. All right, so we'll call this thing a getMessage instead, and yeah, that'll work. Yeah, so it's like the raw message and all that. Yeah, this makes sense. This tracks. I feel like this tracks. Yeah, this tracks. Okay. So we have our static. So we got a parser, so did all that stuff. This thing's upset now for some reason. Oh yeah, missing return type. That's okay. I don't care about that either. Turn that off. So TypeScript, I guess this is an ESLint rule, right? So in TypeScript, you can specify, so here I'm saying like, this is my function name, it's a static function, this is my name, this is my params, this is my body, right? I can specify that return type here and be like, oh, this returns a string or whatever. That's a lie because that's not what's happening right now, but I could claim that. And the nice thing about doing it that way is that this is sort of you defining what your API looks like before you code it up. So then if you say that I'm going to return a string here, and then you return, and there's like some case where you end up returning undefined or returning something else, then you'll get a TypeScript error, and you can go identify those cases. The alternative is to let it infer the return type, basically where it looks at your return statements, or where returns would happen, and whatever types it finds there, it then just uses. So I like to use it that way because it just makes for less refactoring, but it does mean, and it means that your types will be correct. So if you go look at this, or it'll be correct most of the time. So if you then hovered over this thing and we're using it elsewhere, it's the return type it shows you would be the actual return type. So as long as you don't see the errors downstream resulting from you having done something on accident, then you basically, the short of it is you'll still end up getting an error somewhere, just not right here if you're using an infer type. So I still like to do it that way because it's just shorter. Requires less refactoring. So I'm going to add that to my ESLint rules. Turn that off. Okay, so now we've got, let's rename this file also while we're at it, since we're refactoring this thing. Let's call this getMessage. All right. Keep things refactored as we go. So we want to add in here some sort of a field to represent the index, but that's the index within the get message, right? So it's the location of this message, this sort of change, right? This change log, I guess. If we're big, that's probably what you call it, right? It's the location of this change log, the log for this one change inside of the get message. So we can call this get message index or get message position, or let's just call it position. Actually, it's called position. We won't need this outside of this context probably, so we can kind of treat this as temporary. It's required. So we get a number. All right. So we've got our message parts here, right? And this now you can start to see where when you start making type assertions, then you start to lose the protection you had on yourself, because here I said treat this as something we don't know what it is, and then force it to be of this type, right? But in this type, in this interface, I said that this thing had a position that was required. That was a number, right? Which definitely isn't true. That's definitely not true here. The only thing that could possibly come out of here is strings. That's a number. And this field isn't even in here, right? So this at this point is just a lie, right? This is just wrong. So this is the kind of stuff where you have to start being really careful, because you can really get yourself into trouble when you make a claim that just is a lie. So I'm gonna fix the lie immediately, and then at some point in the future, maybe consider not lying about it. So you can see here, now I got my autocompletes, right? We'll set this to the conventional format regex dot last index. So this was the position that we found it, right? So it's a position at the start of the match. Check the chat. And be Matt. Thanks for popping in. Ask what are we making here? Yeah, this is basically how do we take get messages, and then we get a nicely formattable patch notes out of it, and then with some really nice bonus features like the ability to make different versions of the patch notes for different audiences, or parse out references to people from there, or tags, or whatever. Basically making it so you can write all that stuff in one place, and then which is where you're writing it anyway, alongside your code, and then have it show up as really easy to control patch notes. All right, so we'll store our position on there. That way we know where everything is, and now we can log this again and just show that it worked. And then once we have those indexes, now we can basically iterate back through all of our matches that we got. So actually we'll call these things the messages. Let's call this thing messages. Let's call this thing message content. So we get our messages. They look like this. So here's all the different positions. This is now the index position within the string, right? So if we were to go to position 6 inside of here, well, actually, if this is the last index match, because this says 6, right? But if that says 6, okay, so we actually want to store what? Because this is actually the position it would start looking for the next one at, right? So here, because this is position 0, right? And it goes up to here. So this is actually finding the end of the prior match, is what that's doing. Okay, so here's what we can do. We can do this, we can save 2 values here. So we can save this as like start position, and how do we call this? Because there's not like a name for that part of the component, is there? Let's check the commits. Because basically what I want to be able to do is I want to separately describe this part and this part, but I don't know what to call this collectively. This is like what can I call this? This is the, because it's not the description that explains things on the body. It's not the, it's like the type. No, that's already a sub piece of it. What the hell would we call this? Preamble? The what is the word? We're already using all the words that we would otherwise use. Okay, we'll call this start position. So we'll say start position of the message. That's fine, and then we'll say, yeah, here we go. We'll just say start position, and we'll say description start position. There we go. And then we can do here. So this is the nice thing about using TypeScript is then, so I went up here and I changed this type, right? And then I had claimed that this thing was that type, but down here I'm setting a thing called position, which doesn't exist anymore, right? There's another way I could have done this though. If those were going to mean the same thing and I was just renaming it, then I can just do a rename using that Ep2 here and just rename it here, and this will cause that to cascade into every reference up to it. So now you're like, I changed. So that's great. But I actually though wanted to change that because that what used to be the position is now the starting point of this thing, right? So let's do that. That's the description start position, and then we will call this start position is now a separate thing. And so the location of that message parts start position is now going to be equal to the description start position minus the length of the match. Format match dot. So we'll look at the match, which is the 0th item, dot length. So in theory, that gives us what we want. Let's see if that's true. Let's see if that's true. All right, what do we got here? So here we have start position 0, description of start position 6. That looks correct. So that means up here. Started at 0 and it went to 6. So that's that whole section here, which means anything after 6 is where the description starts. Up to position 110, because that's where the next message starts. So if we were to grab all this, so we can get rid of these new lines here. All right, so now here we're unindented, so it's easier to keep track of where we are. So here's position 0 up to 6, right? Which will show up as 1 to 7 here because it's 1 indexed instead of 0 indexed. And then if we were to go here, or no, down here, that is now 103 characters away, right? It's 103 characters away. And if we look down here, we can see its start position is 103. Exactly where it should be. And the description start position is 7 after that, which is probably right. Because it should be 7. And so on. Yep. So that works. That works. Great. So now we know where everything is. And we could then now flip back through, loop back through all these, grab those chunks of text out, and then we can parse those separately as the rest of the contents of whatever's in here. So that is easy enough, or I guess could be easy enough. But the first part of that then is to change this parser. What do we got here? All right, so now we have all of these messages, right? So this is basically find all, what do we call this? Find all messages, no, find all find individual change logs within a string that can contain multiple. Right. So that's what this is. And now we might want to add some new fields to it. So you got these parts. Now we don't know until the next one runs where this one's end position is, right? So that's basically its end position is the start position of the next one, right? But each next one also there would have been a new line before it, so we could skip back one position we wanted to, and that would also be fine. So then what we can do here is now for each message, we're going to find the body and finish parsing. So then that, I should put one more test case in here. Let's put a test case where we have two things back to back. Let's do it right here. Chore. Actually, this is chore. Let's do it here. Docs. Build something. Whatever. Then here's stuff on another line. So again, part of the motivation for all this was that conventional changelog, while a useful tool, doesn't allow for some kind of flexibility that just people have, where people do things in certain ways. They'll forget, oh, I probably should have put another new line in between these because these are two separate things. They forget that, oh crap, I actually made 5 changes, right? But now I have to make one commit, and I have to somehow describe all those as one change, even though it's actually 5, because you're not supposed to have more than one of these kinds of entries in here, right? So part of the goal of this thing is to allow for that just human flexibility. Just people don't do things the way you necessarily wanted them to, right? Okay, let's got more cases in there. Great. So for each message, we're going to find the body. And I think at that point, we'll call it a day because we've been now at this for a while. And then we can talk about parsing the rest of it on the next occasion. So that will be the last bit. So let's do it. For const, this is now message of messages. I find that I tend to refactor the crap out of names for things in the early phase as I kind of figure out how to think about it. So these will probably all get renamed. All right, so for each message, what are we going to do? For each message, we're going to actually we're going to do this with an index. So this is a fun shorthand in JavaScript for iterating over an array of things, so that it just takes on the value and that's that. It's very fast. The more classic way is, save an index. Is less than messages dot length plus. And so that's your classic for loop. I need to do it this way because I need to be able to dip into the next message to look at its starting position, and I can only do that if I know where the current one is in the array. So first we'll take the case where this is the last message. So if I is equal to messages length -1, that's the last one, right? So it's equal to that, then we just set this end position, right? So we're gonna set message, set message.end position. Nope. End position. Oh shit, right? Because I don't have that in here yet, and then also is shadowing this, so I gotta be careful here. So we'll call this const msg equals message I. Put this up here. Okay. Message dot messages. It's bad naming. Gotta fix these names. End position is going to be equal to the end of the string, right? So the very end of the original message. This message. Let's call this thing raw get message. And then messages here is now, we'll call this thing like parsed logs, something like that. Parsed log, something like that. That's a little better anyway. So then parse logs, now we can call this thing log. Easier to reason about. There we go. Log.end position. So this thing is going to be now the end of the string, which is now just called raw get message dot length -1. There's enough of my one error. That's the end. The end goes actually after the last character, so that's actually that length. That's fine. I think that's fine, because then you would, if we're going to iterate over it, if we said it went from one position to another, is that inclusive? I'm not totally sure, because in the start position of the next one, because that position is now at the index in which it starts. At least off by one error. So confusing. All right, I'll keep that like that for now, and then we can just see kind of what that gives us. Okay, so now for the last one, then we're done. And then in all other cases, let me just break here. And then in all other cases, we're going to find the end position based on the next one. Log.end position is equal to the parsed logs at I+1, so the next one, dot start position. And then I want to say -1. I feel like that's right. So then, yeah, so then we should be good. And this means, actually let's do it this way. Let me just do an else, stick this up there, and instead of breaking here, then we can slap the message in there, and then we can say log dot content is now going to be, so let's make this thing exist 2 string. So now this thing is going to be equal to all that text in there, right? So then we can say the raw get message dot I'm going to slice it. Slice. So we're going to start at log.start position, description start position. We're going to end at log.end position. Yeah, there we go. And then hopefully what we should see now is each one of these objects should include all of the text that we are going to need to finish parsing to make up for that one message. Okay, let's see if we did it. Okay, starting at the top. What do we got? So we expected to see here, feature, added some features, or added some feature. So it starts in the right place. That's great. It has multiple lines, ends with a new line. So that is true. So this actually ends with 2 new lines for the next one, right? Which could, like, this is fine, but we might have to have this off by 1 error probably to deal with. We can see all the new lines in between are captured. This is all great. All right, and then we've got the next one should be a chore. So this one also starts in the right place and ends just fine. It's great too. All right, and then we've got docs. So then docs here, update something to docs, doesn't end with a new line. Okay, so that's fine. And then we've got docs again, build this time. Breaks over a line, there's a new line right there. That's all great too. And then got our fix pub div. That all looks great too. Has 2 body sections, ends there. Great. Yeah, this worked exactly as intended. So that's nice. A little surprising. So that is kind of a, so we could have not edited this at -1 if we wanted to, because then that would have captured that final new line too. But there'll always be a new line there, so it doesn't really do anything for us to keep it. It doesn't really do anything to not keep it either, right? Because it's just a new line. We're gonna strip it off at some point anyway. So it could go either way here. It's probably fine. It feels more accurate to do it this way. All right, so that actually wraps that up. Yeah, that wraps it up. So we're gonna commit this thing, and we still haven't solved all these problems yet, but we've now made a really good headway into this part of it, which is given a get message, how do we break it apart into all of its logs that collectively make up that message? And again, this is under the assumption that we're making room for people to have more than one change they want to document per commit, and that these changes consist of some arbitrary number of lines and all of that. So the next phase then is now, given that we've parsed all of this stuff out, then how do we convert these things, right? How do we convert these things into some new kind of a data structure where all this other stuff is parsed? So like if this is a breaking change, then we parsed out that fact. If this is if this has multiple lines, like how do we know which one is the title line, like the main line, versus the body, if we want to separate things out that way? If it closes stuff or does other things, can we pull that stuff out so that stuff doesn't have to necessarily exist inside of the logs if we don't want them to, right? Because it'd be nice if we had the option when we make these change logs. So again, a lot of the rationale for this is making change logs for private code, for a private piece of software like a video game. So we want to be able to do things like we need to be able to then just show our logs to users, basically. When we have things like, closes number 55 or whatever, then this is great in GitHub, because in GitHub that number 55 will link to the pull request or the issue that got closed, which is really great for us as the developers, but that same thing doesn't mean anything to the reader of your patch notes unless they have access to the issues or to the pull requests or to the raw code even, right? And if they don't have access to it, then it's just, why have it in here? It's just confusing to people. So being able to pull that stuff out would be really nice. So yeah, so we need to be able to parse it. So that'll be the next piece. And then once that's done, now we're into the next phase of the game, which is now we can parse a commit message, but now we have to get them, right? So that'll be the next thing. And then once we can get them, now we have the versioning problem, which is that each one of these groups of commits, and then within those, the groups of messages need to now be compiled and put under some header for a version, that's the last piece actually. So there's really actually not a ton to do here, but these things kind of get a little complicated. So it's still gonna be a fair bit of code. So with that, I'll make a commit. If you have any questions, pop in the chat while I'm putting this commit in here, and then we'll call it a Sunday afternoon. So let's do this. Call this thing. Call this a get message parser that can give us each conventional commit matching sub message or whatever. I'm going to put a tag on this one just for practice. Yeah. Okay, cool. I think that's that. I'm going to go ahead and push this. Which means now all this stuff is live right now and available on GitHub. So you can see it's right there on the patchnotes repo, on our public stuff in our studio GitHub. Let's see, refresh this here. So you just see our checked off lists. That's all updated. We see things happened 30 seconds ago, so it's all up to date and excellent. So if you want to refer to source code, it's all there. Yeah, I'll probably do this again on some other occasion. I mean, who knows when? It took 6 weeks the last time to come back and do this. And you know, I don't know how much people are into it, and because it is this very, very specific kind of technical knowledge, and trying to find that balance between having stuff that I can still talk through and explain and teach, but then still solve these weird technical problems that people, you know, more or less care about. It's just kind of a weird thing to stream about. But I do appreciate everybody popping by and watching. Looks like I don't see any questions in the chat, so I think I'll probably just sign off at this point, and wish you all a excellent, what is today, Sunday? Excellent rest of your Sunday, and a great next week. So have a great one, everybody.